I like that one, yeah. You knew X was said the whole time. You never said anything? I'm dying. You know what it was. What the hell? Oh, so you need that. Oh, and here's the... Joseph? No. Oh, Veronica, hold on. Let's give you all your stuff. There you go.
Thank you.
Cool. Okay, so let's see. So we're... Okay. Alright, so let's see. Section 12.4, number 55. Now what you want to be smart about these things. You can do the square root of parts of this. Plus, what's the square root of 9? 3. So the square root of 9 is 3. What's the square root of x squared?
What section is it?
This is section 12.4.
Okay.
Good. And the square root of x squared, assuming that it's positive as x. What other part of the bottom can I do something with? Good. I know 20 is 2 times 10, but why is that not a good way to break it up?
Not even.
Because I can't take a square root of either one of those either. I want to break it up so that I have a part I can do. And of course, 20 is 4 times 5. Square root of 4 is 2. And the square root of 5 is? I don't know. So what's left inside? A 5 and a 1. Okay, let's stop there for a second. So my first step is simplify it if I can. I'm going to put you. And then I see what's really left irrational on the bottom. These guys are completely cool. They're not irrational. I'm going to leave them alone. This is the mess up here, right? And of course, what does he need to fulfill what he needs? What does he need? All right. Why can't I do the square root of 5y?
It's nothing to do with it.
Even better. Why could I do the square root of 9? Because it had 2 3's. So I can't do the square root of 5y because it only has 1 5 and 1 y, so I'm going to give it another 5 and another y. That's the whole idea. Now to make it legal, that sounds like it should be illegal, but I can multiply the top and the bottom by anything I want to, except 0. So if the bottom needs another root 5y, then I have to give the top root 5y to make it legal. It's not, even if you don't want to give it, it's too damn bad. If you want to do something at the bottom, you have to do the same thing to the top.
So if we...
So then does that cancel out the 5y's or just make it...
It doesn't cancel it out. It completes it. So
then you simplify the 5y.
Beautiful.
Takes away that.
I love it.
Okay.
A couple ways to look at this. This is square root of 25y squared, which is 5y. Or half of 5y and half of 5y makes a whole 5y. Is it cool? Either way you want to look at it. You can look at both ways if you want to. So on the top, what do I get? Do I get 15?
No.
Why not?
No, we're going to square root.
Good. Doesn't have a root. I love it. So you get 3 times that over 2x times 5y. Good, because that makes a whole 5y.
10xy.
Beautiful. So then the bottom.
That is still out of the chocolate.
No way. What the hell is that? Can you shut the door? I'll just do a little bit for us. Anybody back in that area? Okay.
So leaving it as the black one is wrong.
Say again.
Leaving it as 3 over 2x.
Yeah, in fact, the whole point of the problem said to rationalize the denominator. So the first thing we did was just to see what we really had to worry about. I didn't have to worry about the 2x that came out because it didn't have a root on it. And the 9 just became a 3. That's nice. But then this is the part that I don't worry about. So the first step wasn't even answering the question. The first step was just me going, let me make this look better so I can see what's going on. That's definitely one of the harder problems because it's not straightforward. You got to uncover it a little bit to see what's really down there. Yeah.
I
have some questions.
Sure.
Hey Jeff.
Yeah.
Quick, 5Y, the 2X you still don't have to worry about because there's no root. But the 5Y, inside of there, there's that unseen 1/2 root. Is that why we got to double it?
No, it's totally seen.
Well, I don't see it. No, inside number 5. You said, remember you talked something about 1/2 roots?
Sure. You could rewrite. Let me just write
Why
this one.
does the 2X not have a root?
Let me just write this piece of it. Don't worry about the 2x. Maybe we should worry about it. What's up?
Why
All
do
right,
you
all right,
said
all right.
it doesn't have
All
a
right. So from the very beginning, we can write this as square root of 9 over square root of 20x squared y. If I remember correctly, you're the one that told me square root of x squared is x.
Right.
So that's why I didn't have a root on it, because it's the answer to a square root question.
Okay.
Square root of x squared is x, not square root of x. And the square root of 20 I can't do, but I can do a part of 20. So I can continue, I can say, okay, that's 3 over the square root of 4 times the square root of 5 times the square root of x squared times the square root of y. Cool? Just really breaking this all the way down. Do you guys see that?
Yeah.
Square root of 4 times square root of 5, square root of 20, square root of x squared is there, square root of y is there. And then you do the parts that you can do. So you get 3 over 2x, and then square root of 5y, because that's still inside. So any way you want to look at it, that's how you can attack it. You can always break the inside of a radical down, or you can try to, into a part you can do times whatever the hell else.
That looks more simple to do it that way instead of how you had.
Well, this was just
multiply it
not
by
as
another-
explicit. We were just kind of seeing 20 is 4 and 5, square root of 4 is 2, square root of 5, I don't know. Square root of x squared is x, square root of y is, I don't know, square root of y is still inside. So this is kind of like not showing all the steps behind what's going on. Here's what we were, this is how we got there. This is how we got there. But dear God, please, the minute I do something up here that you don't see how it went from one step to the other, ask me immediately, right? If you don't say anything, then I think we're all okay with how it got there. But that's how we got there. And then once we're here, we go, who needs something on the bottom to free them from the oppression of the root, right?
Can you
Yes,
do one more? Can you do one more?
Sure.
I just have one quick question. If 3 had a square root next to it, would that be the final answer, or would you still do something to it?
No. So you either rationalize the bottom, in which case the top is going to have to get square root something, or you rationalize the top, in which case the bottom is going to. If you try to do both, you'll just never stop. Well, the top's got stuff, now the bottom's got stuff.
But 3 had it as well. Let's say
No. So yeah, let's do another one, and we'll do like that. So we got another one here, as I've already raised half of them. Okay. So let's do another one. Let's see.
Still number 55. 50 like that too.
Who? What?
50 is like that too. You have.
Oh yeah. So all these are like that. Let's do one like. Oh, let me make one. That should be exciting. I like that. Yummy. So who's got a good first step for me? Besides run away.
4 and 4.
You could do 4 and 4, but can I do the cube root of either one of those? No. Yeah. So good first step is to kind of separate the cube root out. I'm taking the cube root of the top and the cube root of the bottom. And again, I think more of you guys like it like this. 16 is 4 times 4, and each 4 is 2 times 2. So this would be 2 times 2 times 2 times 2.
So you plot one side of 2, so it's a 2 left inside. Right?
Good, I like it. So for this group of
Well, 3
for
out.
this group of 3 2s, what happens?
One of the 2 small.
Yeah, that one has 1 come out to represent them. Right?
and then 2
Good.
X, Y, Z.
And then the cube root of y cubed is y. Are there any y's left inside? No. What is left inside?
2X.
Exactly. So there's a group of 3, which is what that's looking for. Bam. Group of 3 y's. Bam. Poor little 2 and poor little x do it all by themselves. And on the top, it's still just make it right. Cube root. All right. So is this more like what you're talking about, Harvey? The top's in a root. Okay.
That's the final answer?
No.
Oh,
How do I know I'm not done?
Because you want to take out the root there.
Yeah, they told me to rationalize the denominator,
So
right?
then you multiply?
Yeah, so what does the denominator need?
Cube root.
It's a cube root, so how many of each does it need total?
2.
It needs 3, so it needs 2 more of each, doesn't it?
2 more 2X.
You can't do the cube root of 2 because there's only one 2. But I could do the cube root of 8. So I need 2 more 2's to make this work, and I need 2 more x's for the same reason. I really want you guys to see how that's a very, very simple idea. This needs 3 things to work. It's only got 1 so far. Since I'm going to multiply top and bottom to make it legal, I can give it whatever the hell I want to. So I'm going to give it what it needs. I'm going to give it 2 more of these and 2 more of those. Because it needs 3 total. Right? It's almost too easy of an idea. But it's because it's a fraction. I'm allowed to multiply top and bottom by anything except 0. So I'm going to give it cube root of,
4x.
good, 4x squared. Or you can write that as 2 times 2, however you want to write it.
What happened to the other one? Oh, I'm saying, okay, you can't.
Still there.
Okay.
So this is what I introduced. Just so I can give him what he needs, and then the top has to get it too, even if he doesn't want it. It's too damn bad. You just got to take it. And now you just simplify. I'll do the top. The top is 44x squared inside. Whew. All right. Now, what about the bottom?
4x.
Yes, because this is going to be. Let me write it all out. We're going to get 2y cube root of 8x cubed. And what's the cube root of 8?
2.
Times 2.
4.
Cube root of x cubed.
X.
And you got a little y dude down there too.
So, I'm sorry, man, I'm just so confused. How did you even get to that? You said ask questions.
Yeah, but ask questions the minute you lose touch with what's going on. Otherwise, we got to work back to where I lost you.
You lost me when you got into that.
You lost me when you said, Klaus, how you doing?
I knew it. I was waiting. I was like, Carl's got to say something like that. You lost me at hey, man.
No, you lost me pretty much at the second to last right there.
Here.
No, one more down.
Here.
Yeah.
Oh, good. Not too bad. So how did it go from here to there?
Yes.
What is the cube root of 8? Times the other 2 that's already there. Is that cool? Because again, right here, what was it? It'd be 2y times cube root of 8 is 2. What's the cube root of x cubed? And what's 2y times 2x? So you can show yourself that step too if you want to.
Yeah, you could take it out.
It's not a problem.
You just shortcutting it.
I'm just trying to not write as much. Yes, ma'am.
Okay, I got lost where you had, further back than that, where you have the 3, right there, And so, why is the second, we have cube root 4x
Yep.
squared. Why isn't it 2x? Both of those 2x.
You need 2
Why is it-
of it.
oh,
You need 2.
Yeah, so 2 times 2 is 4. Or I can write this as 2 squared x squared. Is that better? That's 1, 2, it needs 2 more. It's 1x, it needs 2 more. Right? Is this, I need 3 total. How many 2's do I have currently? So I need 2 more. Isn't that 2 more 2's? 1x, I need 2 more. And I just wrote it as 4 because that's what 2 squared is, but you can write it as 2 squared.
Yeah, that part was confusing me, but I understand what you're saying.
So here.
2 more, but when it looks, when you write it like that.
Quick fire. Which gotcha. What would that need? Think about it.
9 and 3.
That's what it's got. That's right. So what does it currently got? That's a good place to start. 3 3s. So it doesn't need It doesn't need 3 more 27s, right?
One.
Good God. It only needs
One.
1 more 3, because it needs 4 total, right? So I'm going to multiply by 4 through to 1 more 3, and then how many more W's?
2.
2, because it's a 4 through. It needs 4 total. It's got 2 so far. Whatever you do down here, you got to do up there. Yeah. So here's the cool thing. If you let it be this way, you put that, you designed this, so the answer will come out to be that. Bam. 2, 3 threes. 1 more 3, 4 3 makes it 1 3. 2 W's. 2 more W's, 4 3 makes it 1 W. If you don't like that, you can write, this would be 4 3 to 3 to the 4th, W to the 4th, which is 3W. Because the 4th root and the 4th power will cancel each other out. I just feel like I'm co-teaching.
And the top's the same, right?
And the top, since that's just a 1, it'll just be 4 through to 2W squared. So you get 4 through 3W squared over 3W. And you can't cancel those because they don't have the same root. Nicole?
I get confused with like the top of here, cubic 44x squared. How do you know that you can't break down 44 and...
Because I know what went into it. It was a 1 11 and 2 2s. Do I have 3 of anything? No. So I put it together. I know what went into it, so I kind of know nothing's going to come out. There's not 3 of anything in it.
But you know how in the last problem you did, you took it apart so you could put something into it?
Totally, because it gave me a problem. I didn't create it, so I'm like, I better see if this will break down. So you could take a second and see if that'll break down, but I really want you guys to see you were there when it was created. It's got 1 11, 2 2s, 2 X's, and got 3 and nothing. There's no time, no reason to waste time on it. I knew that because I put it together.
I just get confused on how to know that right away. Like, that it won't break down. Because sometimes I personally try and break down the problem more than it needs to be.
Oh, I see. Well, this is not a good time to ask that question because you're asking more of a general question about if it just was given to me somewhere or something, how do I know not to? And then the answer is just try. Just try to break it down. You'll quickly see it's not going to go in there. This one, I wouldn't even say try. I really want you to understand, you know what it's made of because you put the 44 together with 11 and 2 2s and 2 X's. There's not 3 of anything. No reason to try to break it down. If they just gave me something, then I have to always try to break it down to see if it's going to go anywhere.
Can you go back over just the last step? I understand that the 11 times the 4 gave you the 44x squared. And then the bottom, how did you get that again? I see the 2y.
Yeah, and then 2 times 2 squared is 8. Right? 2 times 4 is 8. X times x squared is x cubed. And I can multiply these because they both have cube root. Right? So I have 2y times what this is.
Okay, that.
Cube root of 8 is 2 times 2 is 4. Cube root of x cubed is x. And then there's a y.
Isn't there a cube root inside the 44? Like, obviously, there is. Like, there's 27 inside the 44, so why wouldn't you bring
You gotta be careful. So
that out?
when, alright, so, let's see.
You just can't do that, or?
Why does this work?
Because 10.
Because 10 has a 5 in it multiplicatively, right?
Yeah.
So that's 5 times 2 over 5, that's why it's 2. Right?
Well,
So if I say 11 over 5, and you're like, well, 11 has a 5, and 5 and 6. Well, why does that not make any sense?
Because it's
Because addition?
Because it's addition, not multiplication. So now, I know that that's easier than what we're doing here, but let me start there. Now here,
44
times 4.
yeah. So if I just was looking at this, and I said, okay, well, it's got a 27, because 27 plus 17 is 44. That's addition. Roots don't work with addition. Same way that division does not work with addition. In fact, roots are even further away from addition in a way.
And so one reason why you'd be able to do something like if it was to the 5th power and you had y to the 4th, the only reason why you could bring the y out and leave 1 y inside the square is because it's
Multiplication. Exactly. In fact, we had the square root of 20 earlier, and what we do to it? We broke it up as 4 times 5. The square roots work with multiplication really well. Why do they work with multiplication really well? Because they're powers. They're really like a 1/2 power here, and powers are based on multiplication. That's why this plays really well. That plays so bad they don't do shit with each other at all. Right? Their moms don't trust each other. They don't play with those kids. So the plus does not work well with the roots because they're not based off of each other. What's the matter? Only you guys are gonna watch it. You were here for it. So what the hell? I'm just waiting for the day somebody gives you a comment. I can't see what you're doing, and you cuss too much. Shut up. You're not Mr. Good. Okay. Continuing this lightning round here. So if I had fifth root of w cubed over fifth root of 16x4y cubed. Think about it for a second. Let me see if this has no power. How you doing there? You got power? I have to plug my phone in, so it's about to die. So what does the bottom currently have? The variables are always easy to see because they're eternally factored, because you can't put them together. The 16 is 4 2s. All right, so this is 2 to the 4th. So the bottom is ruling the day here, unless they say rationalize the numerator, and we do all the same thing we're doing except for the thing on top. Yes, sir? Oh, cool. Thanks, Phil. Yeah, it looks like thanks. Oh, cool. I think this is the kind I wanted to get. You got it from... You didn't get it from Fry's, did you?
No.
No, okay. As long as it's got power, it's more than I can say for me. All right. Thanks, Carl. Shoot. All right, so what's the bottom need?
2.
Yeah, one more 2. Another x.
Y squared.
And y squared. Good. Because it needs 5 things. You see what it has, you give it what it's missing. It's almost too easy to trust. You're like, no, math is not supposed to be that easy. Jeff, what the hell? You just got to really kind of get over how messy this kind of looks. You know why you put that there. Now your whole focus is, what do you get when you multiply those together on the top?
2xy squared w.
So fifth root of 2xy squared w cubed. Yeah, just slam everything together.
And then 2xy.
Yeah, exactly. You'll end up with 5 2's, 5 x's, and 5 y's inside of a fifth root, and the fifth root just cuts them all down to 1. So it would look like this: 2 5 x 5 y 5, right? That's what we did. We just made it do that. So of course it's going to do that. And then the fifth root, jump. Oops, I went a little crazy. Over 2x. Yeah, I'll go a little crazy soon. Not too bad. It's not nearly as bad as it could be. Although right now, if you look at the whole board, this is why you got to focus on just a piece at a time. 12:4. I don't know what the...
Why did we, over here you had 5, the denominator 5, then you have 2 xy squared. How did it just become?
No. What did I do with this? I multiplied it by this. I'm multiplying what I was given by what it needs. So what's 2 to the 4th times 2? 2 to the 5th. All right, 4 2's times 1 more 2 is 5 2's.
Okay.
4x's times 1 more x is 5x. 3y's times 2 more y's is 5y. And we put these here knowing that that would happen. Because it was a fifth root.
How did you just end up with the 2x and y?
Because what's the fifth root of 2 to the 5th? 5 goes into 5 once.
Oh,
5 goes into 5 once. Yeah.
okay.
Yeah, the fifth root and the fifth power will cancel.
Okay, that's really good.
So in the quiz that we're gonna do next time, and then on Tuesday, on Thursday,
Wait, what's up?
on the quiz that we're doing on Thursday,
The quiz.
Yeah.
next Thursday, I'm doing a quiz.
Maybe.
Six?
Did I say so? Yes.
Yeah.
If I said so, then yes, we are. Yeah, it's on the.
Quiz next week?
Yeah, here.
Thursday. It's on the
Yeah,
paper.
it's on here. I forgot. I just made this like right there.
12.4, isn't it?
12.4 is it?
Not officially. I kind of 12.4 was sort of like on the last test, except for the rationalization.
Okay.
So the
Yeah.
only thing on this was 12.5.
Yeah, but I think you keep getting yourself in trouble for this. But I will put one problem on there like this, since this is still relatively new.
And on the test number 3,
Guys, hold.
is this part of chapter 12 going to be on it?
Where are we at? Sorry.
On the test number 3, this section 12.5 to 8 is going to be on the test.
Okay, wait a minute. So anything that was on the test will not also be on this quiz. They will show up again on the final. But we're out of those sections now.
No, she said what for test 3?
Yeah,
The
anything.
sections that we are going to do now, they're
Yes.
going to be on the next test.
Yes. Oh, yeah. So I forgot to change the test 3.
Okay.
Yeah, it should say section 12.5 up through. Yeah, it shouldn't say 15, right?
And the
Can you guys see that? So I changed the dates and I moved some around. I just forgot to say what was on test 3. Test 3, hopefully it's obvious. We'll cover everything that leads up to it.
And chapter 15 will not be on it.
No, chapter 15 will not.
And on the final,
It will be on the final. Whatever we manage to cover. Yes.
The last test we just did was test number 2 then.
Yeah, it said test 3 on the top because it was from an old test from a long time ago and I just forgot to change it. Okay. So if you look at your grade sheet summary, that took a lot of work to make. You can see how many tests are on there. So you know how many tests there are. Okay. So last time we started just a little tiny bit into section 12.6, but I want to go back for a second. I want to make sure you guys can do problems like this here. So first off, recall. Here's an easier problem. Just make sure y'all remember how to do this. How do you do this here?
Distributing.
Alright, so what do you get?
18x squared minus 21x.
So you just put the 3 and the 7 together, of course, because then you can multiply those, and then these guys just kind of like, right, I want to make a big point of that. So there's no, you wouldn't say, well, why does the 3 not go to the y? Well, that's silly, it did. You put it together with the 7, and they're all together in one term, right? So that's kind of weird to even think about. But then you start thinking about it when it has roots in it. You suddenly start thinking everything's different now. No, it ain't. So if I throw some roots in there,
Just looks more confusing itself.
yeah, but what can you multiply? Can you multiply root 2 times 2?
No.
Hell no. Why not?
But you can multiply the other one.
Yeah, of course. Just like that x, you wouldn't try to multiply by 6. But x times x you could do. So you put together the stuff that you actually can. Yes, ma'am.
I have a really stupid question.
Cool.
In that, do you multiply first or do you do the parentheses first?
In general, you would do the parentheses.
Okay.
The reason we're distributing is because what could I do in the parentheses?
Subtract the...
Is there any like terms in there?
No.
No, so you can't do it. So this is like 2x minus 1.
Yeah, okay.
But you're good. If there was something I could do in here, obviously I'd do that first, order operations. The only time we FOIL or distribute is when I can't do what order operations normally wants me to do. Right? And we're not doing anything illegal because, if I've shown you, I'm sure I've shown you this before. 2x plus y is x plus y plus x plus y, which is 2x plus 2y. So the shortcut is just bring. So I'm still using order operations. I'm just being smart. That's a coefficient, and that means that many things adding. So that's a little weird. It actually works the same way here, believe it or not. But what's the square root of 2 times 2 square root of 3?
Square root of 6.
Yeah, you put that with what it can go. It's sort of like x times 2x. It'd be 2x squared. That would go with what it can go with. It's still multiplying the 2 also, isn't it? Because it's all right there. But you just can't put those together. Minus square root of 10. And unfortunately, I love when people get here and then they somehow go here. Where'd that come from?
You can't do it. Subtract 6 minus 10.
Yeah, 6 minus 10 and negative 4. No. Are these like terms?
No.
Hell no.
So then you will have to break it.
Oh, so that's the final.
Now, this is kind of going back to the earlier discussion we had. What went into making 6? 1, 2, and 1, 3. Can you do the square root of either? No. What went into making 10? 1, 5, and 1.
So now
So that's the final answer?
That's the final answer. That's it. Because I know I'm not going to waste time trying to break these down because they were broken down when I started. And I could see right then that nothing would go. Right? Now, if I had square root of 2 times square root of 2, that would create something because now I have 2 of something. That would actually be something I could do. Let's try one like that.
That's a perfect bonus question.
Excuse me, come on. Don't be overly optimistic there, Harvey. Young man. Ooh, I like that promise. Yummy. Ooh, let me do this. Wait. There we go. Now, what are you going to do with that one? I like it. So next,
You times 7 and 11.
that's if you don't want to do what?
Times 7 and 11.
Well, that's one thing we'll do. But in general, what are we going to do? Yeah, distribute, and otherwise known, some people know it as FOIL, right? Which I personally don't like you're taught that, but you all know it. It's not going to kill you, so it's fine. Because all it is this guy gets a term, and this guy gets a term. Why the hell do you need FOIL for that? There's 2 things to distribute. You don't need FOIL. And if I put one more term in there, FOIL doesn't work anymore. It's middle first thing, last first middle. What the hell? It's just that goes through, that goes through. That's all it is. So here, what can I do?
3, 4, 3.
3 square root of 14.
And then plus.
Minus 6 square root of 77.
Good. That's a big number, but why would I not waste any time?
Because
Because it's 1, 7 and 1, 11. I'm not going to waste time trying to do that. And then I got to do this guy.
plus square root of
22.
minus square
2 square root of 121.
I like it. And of course, another way to look at it, what's square root of 11 times square root of 11? It's 11, right? Half of 11 times another half of 11. Or what's the square root of 121? It's 11. Either way you do it, you're going to get there, right? So then you look, any like terms? No. But the only thing I can do, 3 square root of 14 minus 6 square root of 77 plus square root of 22. And square root of 121 is?
11.
And 2 times 11 is? There you go. And people are going to go further, but you can't. No like terms, and none of the roots are simplifiable. Right? So I have to stop. Okay, I just want to make sure you guys can do those. Those are not a big step away from what we've already done. And it's old news, foiling and all that kind of stuff. Old news. So what about some new news? Yeah. So last time we did a quick one. I can't remember exactly what it was, but here's one. Pick enough number to do there. 4 is safer. So can I just subtract 1?
No.
Why not? Yeah, what is the square root of x plus 1 minus 1? It would be the square root of x plus 1 minus 1. It doesn't get you anywhere, right? But why is my x, why can't I solve for it? I want to be able to move that 1, don't I? So to do that, I have to somehow get this stuff unstuck.
Times square root of x plus.
All that is
I understand what you're doing that for, but then you're just going to move the problem over there. So what's a more direct way to kill a square root?
you have to times it both sides by 2.
Not times by 2, but square. So if I square both sides, whatever I do to one side, I've got to do the other side, right? And the square root and the square do what with each other?
So it's just x plus 1 now.
Good. So it's just x plus 1 equals 16.
Minus 1.
Now I can subtract 1 finally because everybody's free.
X equals 15. That's a good bonus question.
I'm going to make your own test. And you're going to ask some interesting bonus questions. All right, so how do I check this? Plug it in. So go back to the original problem. If I plug in 15, what do I get?
16.
Square root of 16 is? Check. Sweet. And to be honest, it's not just an option. You have to check these. And I'll show you a reason why. So what would I do here? So how do you kill that square root? Square? So what do you get on this side?
3 minus 6 equals 49.
Yeah, if that goes away, so 49.
Plus 3.
Yeah, minus 3. Plus 3 would make it 6. It's worse. Minus 3. Negative x equals 46. I just don't need you there anymore. And then, yeah. You know, oh, yay. Well, that's completely
But
wrong.
negative numbers cannot go.
No. It's not even that. Be careful, because it's minusing it. So if I go to check it, that's not going to be the problem. So what was the original equation? It was square root of 3 minus x equals negative 7. That's actually the problem. So when I plug a negative 46 in, let's try it. 3 minus negative 46. Yeah, 3 plus 46 is 49. Square root of 49 is 7. Shit. So remember, square root has to come out positive. So actually, I was kind of hoping nobody would say it, and I was actually at the same time hoping somebody would. But because it started off as square root equals a negative, you didn't have to do any work. You just stop right there and say, it ain't never going to work. Or something more grammatically correct. Right? You can say no solution. There's no way a square root can equal a negative number. But if you do the work, it actually comes out with an answer. Math says, you really? You want to go? All right. We'll get somewhere. It ain't anywhere that's worth anything. Maybe. Thanks, Ron. All right. So, what about the next level then? A whole another level. Oh, okay. Next level up would be this. And this is where we really see the need for checking, because that I can catch. If you ever have the square root equals negative, you could just stop right there. Right? But what about if I have this here? Now I got to make it work. Let's see if we can make it work. Okay, that.
When you
Okay.
have a cube.
Wait, don't say anything. Okay, that'll work. Okay.
Square.
Yes, good. All right. So if you square this side, you have to square that other side. Now be careful, this is not x squared 9 or something weird. What do you have to do to this?
X minus 3.
Yeah, it's x minus 3. So you guys do that side. I'll do this side. I'll do all this work here. Okay. So that's a really easy mistake to make, is just put there x squared plus 9 or something weird, but you're missing the middle term. It's never going to come out right. Very often it's going to come out weird. Yes, ma'am?
Can you do it again, like slow down, please?
Say again?
Can you do it again and then just like slow down?
Okay.
Actually moving in slow motion.
Alright.
Same problem.
Sorry.
Alright, so how do you kill the square root? Okay. And what does that squared mean? Is that cool?
Yeah.
Alright, and that's pretty much where we were. So now, the whole reason I want to do this, I can't work with anything that's stuck inside a square root. So that's my primary focus, is killing that square root. Anything else that has to happen at the same time, I just got to live with. So on this side, what do I get?
X squared minus 6x squared. X
Plus 9.
squared.
Plus 9. Negative 3 times negative 3 is 9. Negative 3x is minus 6x, right? Is that cool? Now, does anybody have any idea what I do here?
Yeah,
Do you have
you
to factor?
subtract 3 to 9.
Oh
Will
wow.
it be?
That's one thing.
You pass the X. You add the X.
So real quick, guys, hold on. Anytime, I don't care where the problem starts, if you get to the point where you can't get all your x's together because they have different powers, you have to get it equal to 0 and factor, period. So just because we leave a section, you should know this by now, doesn't mean that suddenly we don't ever have to do that again. And it doesn't mean just because I'm going to give you a problem on the final. It means every other section could possibly need other section stuff before it, period. So we've learned what to do. Anytime I'm trying to solve an equation, I got a power that's different. I can't get all my x's together. I need some other way to solve it. I get it equal to 0 and factor. We know this. The reason we've learned that is because it's going to happen a lot. And here's just one more place it's going to happen. So how do I get this equal to 0? I just subtract x. Subtract 3. So I get 0 equals,
X squared minus 7x.
and that's completely factorable. Thank God, because we haven't officially learned quadratic formula yet. I don't think, have we? No. Teaching too many classes. Okay. How do you factor this?
X minus 6, X minus
Yeah. 6 and 1 make 7. They're both negative. They're golden.
So now you have to check both.
Beautiful. So you have to check both answers. Just like if you have an equation with variables on the bottom. Why did I have to check that? Because some value might make the bottom 0. So we've got to make sure it's not going to freak the equation out. Some value here could make this not work, make it square root equal negative. So I've got to throw that out. So what are my two possibilities here?
6 and 1.
6 and 1. All right, let me make sure before I go any further. Is that cool, all that stuff? Right? You have to square at the beginning, and that's what got everything in motion. I had to multiply it out. Oh crap, now I got to square on my x. I got to get everything on one side and factor. Right? So it kind of leads you down this path. Now if I were to check this stuff, so I start off with square root of x plus 3 equals x minus 3. So what about 6?
6 plus 3?
What's the square root of 6 plus 3?
9.
Square root of 9 is 3. What's 6 minus 3? Check. X is 6 is good. That one's good so far. It doesn't mean one's bad automatically. You've got to check one also. They could either both be bad, both be good, or one of them's bad. You just don't know. So what if x is 1? 1 plus 3? 4. Square root of 4 is 2, and 1 minus 3 is? Aww. And real quick, again, anytime math gives us a bogus answer, it is not math's fault. The minute we squared, we lost information about it. Look, if x is 1, what kind of a number is this? 1 minus 3 is negative. But we squared it. And when you square a negative number, you get positive. So math gives us answers for what we got here, and then we got to go back and go, oh shit, we did something weird here. Let's see if that screwed it up. And yes, it did. It gave me one extra answer than was really there. So don't. You already think math's bad enough. That's not math's fault. Yes? The answer is just 6, because the other one didn't work. Good.
If both of them don't work, it's just a solution.
Exactly. If both of them don't work, no solution. Oh, sorry. I just erased that. Sorry. These things happen. Here, you guys try this one. Oh, let's see if I can make it work. Okay, that's good. Yeah, that'll work. Yeah. Yeah. Should work. All right. Oh, I see. Okay, sure, you can do that one. You can also subtract 5 with x squared minus 4 and factor it.
Oh.
But there's no reason to put plus or minus yet. It's after you do square root. That's sort of like the next chapter. Wait, wait, minus 5, you get to subtract 5 then. Plus 2x is going to get minus 5, this 1. 1 minus 5.
Square minus 4.
Which is that? Yeah. Okay, sure. Equals that, and then you get everything on one side.
And then put it back in.
Real quick, 5 minus 3 should be 4. So if I square 5 and square 3, I get 34. Because I'm using my x minus 3 squared is x minus 3 minus x minus 3 is equal to 4. So if you have an x minus 3 squared, you can write it as 2x minus 3. Oh, when it was another square, then you have to multiply that out. X squared to the squared, x squared to the 6x, x squared to the 9, everybody's. Yeah, these are the monster ones.
You're trying to get it to 0.
No. No, that's at least one answer. Yes, and now you gotta check it off. Yeah, because what makes that convex is two. What makes that convex is more is XX, 4 is and each one, I'll make it a 0. Yeah, we got X equals something. X gotta be the same thing as 0. We'll make this 0. Or 7 equals 0. I said that one equals 0. Or the other one. There you go. And the other is. Yeah, just
No solution.
By the way, somebody might come in. I just remembered he was supposed to come last Tuesday, but I'm being evaluated this month. Every 3 years, full timers get evaluated. So we'll see if he comes in or not.
Oh, you're full time?
Yeah. Thank God. I lived the part-time life long enough on the East Coast, working at 3 different colleges, no office hours because you didn't have an office. I mean, it was crazy. So full-time is nice. Benefits are nice too. You're gonna these go away, right? And this is x squared plus 1, right? No, it's not.
Why not?
Please yell at me for that. Come on.
X minus 1 and X
Guys. X minus 1, anything squared is that thing times itself. So you have to write that out. Again, squares do not play well with subtraction. They will not distribute. They're not based off of each other, so they can't go together very well. But if I write it like that, then we have an accepted process to do here.
X squared.
Now, some of you guys freaked out that your 2 x's go away, but why would you care? That's less to worry
That's
about.
why I said.
It's awesome. So subtract 5, add 2x. I'm doing that, of course, because I have one. Oh, there it is. There we go. Real quick. I'm doing this because I have one x variable with a different power. So what I have left on this side? And then that. So x is. And then you have to check them. I'll let Ray take over right now. And do the evaluations real quick, and then we'll see how much we could do when I get back in. I don't know. We'll see if there's any time left over. Probably not. So Ray, just make sure that you write a lot. No, come on.